back to do a little bit more science. Okay, so we've been talking about motion and forces. And I think this is a lot of fun because I think we come to realize that simple forces like pushing and pulling can affect motion. It can affect the direction of motion. It can affect the speed of motion. So it's really a fun subject to talk about. So I had you watch the video again on forces in motion, a different one today because I liked it. But I really liked it because basically what they said is that forces like pushing and pulling can change the direction of things. And that's exactly what we're going to talk about today, how forces can change the direction that objects move. And they also talked about how pushing and pulling can make objects stop. So I like the example of the balloon. You make a balloon stop blowing away by pulling on the string of it. So when you really think of it, a lot of things that we push and pull, we're changing the direction of them without really realizing that it's really those two major forces, pushing and pulling. So I think it's a very interesting concept, and I liked it. I know some of you went outside yesterday. I know Charlie Veith did. I'm going to mention that because I saw it. Went outside yesterday with his soccer ball and was changing the direction of things and pushing on a swing. These are all things that you can do out in your backyard. Mrs. Rooney wants science to be alive. I want you to go out and try these things in your backyard too. So kick a ball diagonally. See which is going to be faster, if you kick a ball or if you dribble the ball. So try some of these things out in your backyard. Since I know a lot of us have to stay right close around our house, use your backyard as a science laboratory if it's nice outside, okay? This is also something that you could do outside today, some of these little experiments that I'm going to show you. But what I want to do first is I would like you to go into, since we just watched the video, I want to talk a little bit in our science workbook, and then I have a quick little thing that I want to show you that goes back to the video as well, okay? So if you will open up your science workbook to page 57, okay? Page 57, all right? Very good, all right. Take a look at the two men playing basketball. Okay, take a look at the two men playing basketball. All right. Do you see the guy here in his blue shirt, his blue jersey? Okay. So he's shooting the ball. What direction was that ball traveling in? Where was that ball trying to go? Exactly. He was trying to get it into the basket. What happened? Take a look at this picture. What's going to happen? See this guy right here with his hands right there? He's pushing against that ball, right? So he's using that force of pushing that ball to change what's going to happen to the ball. Where's the ball going to go? Is it going to keep going towards the basket? I don't think so. Look at his hand. It's right there on there. It's going to change the direction that ball is going to go in. So his force of pushing, he's not pulling the ball closer to him, he's pushing that ball. This guy in the white jersey, he's pushing that ball as this guy's trying to make it into the basket. The force of pushing is going to change the direction of that basketball. That basketball is going to go back towards this guy in the blue jersey. Okay? So the force that stopped the basketball from continuing to move was a push. Exactly. Okay, so if I'm looking at this, the question I would say is, did the basketball player use a push or pull to stop the basketball from moving towards the basket? Very good. He used the push. Remember, push is you send things further away from you. Pull is you bring them in closer to you, okay? All right, so let's go down here. Let's take a look at the three pictures that we have down here, okay? Which pictures show someone using a force to change the direction that the ball is moving in? Let's take a look at them. Okay, let's take a look. All right. Which pictures show someone using a force to change the direction that the ball is moving in? Okay, let's take a look at this first one. All right. So what are they doing? They're kicking the soccer ball, right? Okay, so let's think about kicking as a push or a pull. If you're going to kick something, what's going to happen to if they're going to kick the ball, what's the ball going to do? It's going to go further away from them, right? So when something goes further away, we're using which force? Very good. We're using a push. So by kicking, she or he, I'm not sure, is going to push the ball away from them. Very good. So we're going to circle that one. All right, let's take a look. Volleyball. All right, which direction was this ball going in? It was coming over the net, right? What is this volleyball player trying to do? They're going to try to stop it, right? Well, let's think about it. When you put your hand up, think about the basketball player. What are they going to do? They're going to try to send that volleyball what? Back over the net. So they're going to send it away from them. If we're sending something away from us, what are we doing with it? Very good. We're pushing it. So is that a force to change its direction? Yes, it is, if you're pushing. Okay, now let's take a look at what they're doing in this last picture. Okay? What are they doing? They're having a catch, right? So each person is doing what with the ball? They're throwing it back to the other person. Does that change the direction? Yes, it does. It changes the direction of the ball. It's going back and forth, back and forth. Well, which force is sending it back and forth? Pushing or pulling? Pushing or pulling? Okay, well, it depends. It could be both. So if she's catching the ball, she's pulling it closer to her and stopping it, right? That's changing the direction of the ball. It's not going to keep going past her. She's pulling the ball to her and stopping it. When she gets ready to throw it back to her friend, she's pushing it away from her. So actually having a catch changes the direction that the ball goes by both pushing and pulling. It all depends. If you're catching the ball, you're pulling it closer to you and changing the direction. You're letting it stop. If you're throwing it back to your friend, you're pushing it away from you. So really, forces are pushes and pulls. It all depends on what you're doing. Okay? So it's really easy when you think about it that way. Today, I want you to think about different things that you're doing and think to yourself, am I pushing something or am I pulling something? Each action you do, if you change the direction of something, it's going to be by pushing or pulling, okay? Now, go ahead and turn the page and just take a look, okay? Just take a look at this page. All right. Take a look at the bowling balls. What happens when you go bowling? Right, you want to knock them all down, but that doesn't always happen. It certainly doesn't happen to me. When you throw the bowling ball down the alley, it hits a bowling pin. Does it hit all of them at the same time? No, it doesn't. Very good. What happens is the bowling pins start to fall and hit other bowling pins. They bump into them. So they start to push the other bowling pins, which changes their direction to falling down. So when objects touch, they push one another. And the push can make the objects change their direction and speed. So if you think about it, when you're bowling, those bowling pins are standing next to each other. When one bumps into the other, it changes its direction. It makes it fall down by simply pushing it. You're not pulling those pins closer to you, you're pushing them. All right, in the video, he also talked about how people aren't the only thing that can change, aren't the only forces that can change the direction of things by pushing and pulling. He gave 2 examples. Do you remember what they were? Wind and water. Very good. Okay. So if you can find a note card or a piece of paper, I want you to pretend like this is a windmill and you're going to be the wind. Okay. All right. Blow on your windmill. What happens to your piece of paper? It changes its direction, right? Because you're pushing it with the air. The air is pushing it, okay? All right, now what I want to show you, and I'm hoping this will work, is he also used the example of water. And he showed how the water makes that wheel spin around. Well, I don't have a water wheel in my house. I have a lot of things, but a water wheel is not one that I have. What I want to show you is I want to show you how water can make things move. I'm actually going to call in help on this. Patrick, can you come here a minute, please?
Yep.
Okay. All right. Mr. Rooney helped with math today. Today, Patrick is going to help with science. All right. I need you to hold the camera down so that they can see my bowl of water. Okay? Hold it right like. All right, friends, be patient. Wait, no, we're not getting it. Right like that. Okay. All right. I'm going to put my goldfish in. Actually, they're Patrick and Cormac's goldfish. Okay? I'm going to put them over in this corner right here. Okay? Now watch carefully. I'm going to pretend like this water is like at the water wheel, okay? And watch and see. Let's see what happens to our goldfish when I pour the water in. What do you think might happen? What do you think might happen, Patrick?
They'll dissolve and get like mushy.
Ah, Patrick said they might dissolve and get mushy. They might if we keep them in for too long, but we've been talking about forces.
Oh.
So do you think they might push or pull the fish?
Push.
Push. All right, let's see. All right, you ready? All right, I'm going to pour the water in. Perfect, just like that. Okay. Are they pushing it? They did. They pushed the fish, the water. Thank you, Patrick.
Yep.
The water pushed the fish away. They moved its direction, okay? So people aren't the only thing that can change the direction of things by pushing and pulling. Wind and water can do the same thing. All right, I hope you had fun with science today, and I will talk to you later. Bye-bye.